So students, this question is about the projectile motion in which you see that what they are saying, an arrow is aimed horizontally, okay? Which means that, for example, if this is that arrow which was thrown horizontally, it means that it has all the velocity, initial velocity along x-axis, all right? And what is the distance between this arrow and the target, that is 20 meter. It means that this arrow, either it will hit the target or not, it will horizontally cover how much distance, that is 20 meter, due to the horizontal component of its motion, which is due to the horizontal component of velocity. Okay, now, and we also know that the its vertical component of velocity, initial component of velocity, is zero because it is purely thrown horizontally. But what happened? It missed the target and it hit 0.050 meter below the target. It means that its trajectory is parabolic, all right? So if I draw like this, okay, students, so it means that the arrow hit exactly at this point. Okay, so how much displacement it covered? It covered negative 0.50 because this is the initial position, all right? Okay, and this is the final position. So how much it has covered? This is the final position, so it has covered vertically downward how much displacement, that is negative 0.050 meter, that I will later use in the equation. So in this question they are asking what is the initial speed of the arrow. Okay, initial speed as you see is purely along x-axis. That's why first of all we will prefer to use the kinematic equations for x-axis. So we can directly write equation that is 20 is equals to initial velocity multiplied by time, but it is good if we proper follow the procedure. Okay, so this is initial velocity times t plus 1 over 2 acceleration along x-axis time t square. So you remember we had neglected the air resistance, that's why ax is 0. There is a no force in the x direction to oppose it, that's why it is 0. And this is the 20 meter, okay, and that is the initial velocity that we want to find out at the time t. So in this is our first equation, and we see we have a two unknowns. It means that we have to first find the time. And remember that in the projectile motion, either it doesn't matter that how far the object is falling, all right? How far, if you are throwing an object with a different horizontal velocity, so you see, for example, this is a trajectory, and if you increase the velocity, okay, if you increase the horizontal velocity, it will now, okay, it will hit the, it will cover more horizontal distance. But remember that time taken is same, because at the end of the equation you will see that time is actually dependent on the distance covered, right? Is dependent on the vertical distance covered. Okay, but let's properly find out the time once again. Now we will apply kinematics equations for y direction, because it will give us an equation with which we can find the time. So students, delta y is equals to initial velocity times 1 over 2 acceleration in the y direction times t square. Okay, so this initial velocity along y is 0, and what is a displacement covered vertically downward, that's why 0.050 is negative, is equals to 1 over 2 into negative 9.8, that's acceleration, t square. So you can simply solve it, and let's see what is the time that do we get. So students, we get 0.1 second is the duration in which it covered this vertical displacement. Okay, and in the same time it covered horizontal how much displacement, that is 20 meters, horizontal distance, that is 20 meter. Okay, now we are going to use equation 1, and you remember that 20 is equals to initial velocity along x-axis times time taken, that is 0.1, and what is the value? of the initial velocity, that is 20 over 0.1, that is obviously 200 meter per second. So if you will throw with this speed, then it will cover this much. So it means that if you want to, for example, hit the target very close, then you must increase the velocity so that it may hit somewhere in the middle. Okay,